डियर फ्रेंड्स, नमस्कार मित्रों। पिछले वीडियो में हमने सीखा जाना रिफ्रैक्शन की इंसिडेंट रे और इमर्जेंट रे के बारे में। That these two rays are always parallel to each other. In this lesson 3, you will come to know in detail about the refraction when the ray enters from denser medium to rarer medium. I hope you are continuously watching my videos and trying to learn the things at your own way. In the same sequence, this lesson 3 will definitely help you out. Keep watching, keep learning. So let us begin with the third lesson. Lesson number 3, we will discuss about refraction from denser to rarer medium. It is quite interesting to learn about this topic. This time I am taking water as a denser medium and as usual air as a rarer medium. This is the normal ray and the incident ray is traveling from denser to rarer medium. These are angle of incidence and angle of refraction. Such rays always found to bend away from the normal, that you can see here also. It is observed that with increase of angle of incidence, in such case the angle of refraction also increases. At certain value of angle of incidence, the angle of refraction is found to be 90 degrees. This particular angle of incidence is known as critical angle. For this angle of refraction is found to be 90 degrees. This is the different feature if we compare with the refraction from rarer to denser medium. So this angle of incidence, for which angle of refraction becomes 90 degree, is known as critical angle. So this theta c is critical angle. What it is? It is the angle of incidence for which angle of refraction is 90 degree. Only and only when the ray is traveling from denser to rarer medium. If we follow Snell's law, we will have mu 1 2 is equal to sin theta I upon sin theta r. Here if theta I is equal to theta c, then theta r is equal to 90 degree. Then mu 1 2 is equal to sin theta c upon sin 90 degree. Everyone knows that sin 90 is 1, so it comes to mu 1 2 is equal to sin theta c upon 1, which implies mu 1 2 is equal to sin theta c. But the refractive index always given for denser medium. All the tables of refractive indices are given for denser medium. So if you want to express this refractive index in terms of the refractive index of denser medium, then we will use this equation which we discussed earlier also. So mu 2 1 is equal to 1 upon sin theta c. So this is the relation between refractive index of denser medium and critical angle, and this equation shows the relation between refractive index of rarer medium and critical angle. One more interesting phenomenon related to this you will come to know: if we increase angle of incidence greater than critical angle. That is, if theta I is greater than theta C, then it is quite interesting to see what will happen. So let us see through the diagram, taking the same pair of optical media, air and water once again, and now we are taking this theta I greater than theta C. Then it is observed that the refracted ray also lies in the same medium. It seems like the ray is reflected, but it is happening because of refraction. So again we will mark here angle of refraction theta R, angle of incidence theta I. In addition to those two angles, we mark one more angle here, which is the remaining angle with the normal made by the refracted ray. So in this case, when angle of incidence is greater than critical angle, the angle of refraction theta R is greater than 90 degree. That is obtuse angle, and the ray seems like reflected ray. This phenomenon is known as total internal reflection. So when does it occur? It's very clear from this discussion that when the ray is traveling from denser to rarer medium and the angle of incidence is greater than critical angle. Why it is known as total interreflection? Because not a single part of such ray is transmitted to the rarer medium. That's why it is known as total internal reflection. So it's quite interesting to see when the ray enters from denser to rarer medium, then with increase of angle of incidence, the angle of refraction also increases. As we increase angle of incidence, the ray deviates more away from the normal, and at certain stage it is found to be parallel to the interface, that is parallel to the line separating two media. This angle of refraction is 90 degree, and this particular angle is known as critical angle. Then we had seen that how this critical angle is related to refractive index, and we obtained the relation mu to 1 is equal to 1 upon sine theta c. Then we had seen if angle of incidence is increased beyond the value of critical angle, then the refracted ray lies in the same denser medium and angle of refraction becomes 90 degree. This phenomenon is known as total internal reflection. So how can we define total internal reflection? If ray enters from denser to rarer medium such that theta I is greater than theta C, theta R is greater than 90 degree, and refracted ray lies in the same denser medium. This is known as total reflection, internal reflection. So thanks, dear friends. In this video you came to know about the refraction when the ray enters from denser to rarer medium, critical angle, and total internal reflection. In the next video you will learn more about this phenomenon, total internal reflection. Thanks for watching the video. Thanks for showing your interest. Keep watching, keep learning. Thank you. We will meet very soon. Thank you very much.